Let us revise about the phenomena called adsorption and the factors affecting the adsorption. Now, first point, what is the meaning of adsorption? Now, adsorption is a phenomena in which the concentration of molecules of a given substance is more at the surface than inside, or we write then in the bulk. Bulk means inside, right? So the concentration is more at the surface than in the bulk. That's why adsorption is called a surface phenomena. And the most important type of adsorption is the adsorption of a gas on solid surface. Gas on solid. The most important type of adsorption is the adsorption of gas on solid, like we use H2 nickel, we use H2 platinum, and so on. The next point is the interaction between the solid surface, which is called adsorbent, at which the adsorption takes place, and the gas molecules, and the molecules which gets adsorbed, called adsorbate. So the interaction between the solid surface and the gas molecules may be a weak van der Waals forces, means the physical in nature, or maybe a strong chemical bonds. Strong chemical bonds, the bonds are mainly covalent in nature. So on the basis of this, on the basis of the nature of the interaction between the adsorbate and adsorbent, we have two types of adsorptions. One is called a physical adsorption, or this is called a Physisorption, and the second one is called chemical adsorption or Chemisorption. So this classification is very, very important from the examination point of view. And the first point is, in this case, the weak van der Waals forces exist. This VWF stands for van der Waals forces exist between the adsorbate and adsorbent. Now in this side we have strong chemical bonds present. Between the adsorbate and the adsorbent. Now second point is adsorption is an exothermic process, so the heat is evolved. Now in this case the enthalpy of physical adsorption is low. It is in the range of 20 to 40 kilojoules per mole. So less amount of energy is released because the interaction between the solid surface and the gas molecule is weak. Now in this side the enthalpy of chemisorption is high. Enthalpy of chemisorption is high because the strong chemical bonds are formed and the amount of heat evolved depends on the nature of the interaction. So it is in the range of 40 to 400 kilojoules per mole. And that's why the physical adsorption is reversible, while chemical adsorption is irreversible. And this physical adsorption is non-specific. Any gas can be adsorbed on the solid surface. And chemical adsorption is specific. Only those gases can be adsorbed which can cross the energy of activation barrier before they get adsorbed. And the last point is physical adsorption is a multi-layer phenomenon. Many layers can be formed on the solid surface, while chemical adsorption is a monolayer phenomenon. So these are some points on which you can differentiate between the physical adsorption and chemical adsorption. The next, the factors affecting the extent of adsorption. Factors affecting adsorption. So number of factors affects the extent of adsorption, and the extent of adsorption is expressed in terms of x by m, where x stands for the amount of the adsorbate and m stands for the amount of the adsorbent. Now the first factor on which the extent of adsorption depends is the nature of the adsorbent, mean what type of solid you are taking, nature of the adsorbent. Now x by m, the extent of adsorption increases with increase in the surface area of the solid, increase in the surface area of the solid, and the solid should be porous so that it can collect more number of gas molecules on the surface, and the surface area can be increased. Surface area of solid can be increased by taking the solid in the powder form, taking solid in the powder form. That's why the powdered charcoal is very, very effective in adsorption of gas molecules on its surface. Now second factor is the nature of the adsorbate. Nature of the adsorbate, mean nature of the gas molecules. Now extent of adsorption is directly proportional to the critical temperature of the gas. And this extent of adsorption also increases with increase in the ease of liquefaction of gas. Ease of liquefaction of gas, and is directly proportional to the intermolecular forces of attraction. Intermolecular forces of attraction. Intermolecular forces of attraction between the gas molecules. So x by m depends on the critical temperature, ease of liquefaction, and the intermolecular forces of attraction. For example, ammonia has a stronger intermolecular forces of attraction than the nitrogen gas, or we can write the critical temperature of ammonia is greater than the critical temperature of nitrogen. Therefore ammonia is adsorb more on charcoal than nitrogen gas. So the third factor is the effect of pressure on the extent of adsorption. Effect of pressure. Now the extent of adsorption, the x by m, increases with increase in pressure, and the graph between x by m and pressure at constant temperature is known as adsorption isotherm. Adsorption isotherm. This is very, very important term, and the relation between the x by m and pressure is given by this equation, which is known as a Freundlich adsorption isotherm. Freundlich adsorption isotherm. This is very, very important equation, and this is a graph between the x by m and the pressure. X by m and pressure, and the shape of the graph is like this. This is at given temperature T. Now at low pressure, this equation is reduced to K, x by m equals to K into P. So there is a linear graph, x by m increases linearly with pressure. Now at high pressure, it attains a saturation level, and x by m is independent of pressure, so we write x by m is equal to K. And in the intermediate pressure region, this is given by a Freundlich adsorption isotherm. And in this case, and we can take a log of this Freundlich adsorption isotherm equation as this: log of x by m is equal to log of K plus 1 by n log of P. So this is a straight line equation. So if we plot a graph between the log of x by m and the log P, it gives a straight line in which the slope is equal to 1 by n. So we can find the value of the n, and the intercept is equal to log of K, where K stands for the adsorption constant. Now next is the fourth factor, that is effect of temperature. Now since adsorption is an exothermic phenomena, adsorption is an exothermic phenomena or exothermic process, therefore the increase in temperature decreases the extent of adsorption. And the graph between the extent of adsorption x by m and temperature at constant pressure is known as adsorption isobar. Another very, very important term, adsorption isobar. Now in physical adsorption, we have weak van der Waals forces, so as a result the extent of adsorption decreases as temperature increases. So this is a graph. This is for physical adsorption. This is the adsorption isobar. Now in case of chemical adsorption, as you know that no chemical reaction starts until and unless the reactant molecules cross the energy of activation barrier. Now in this case also, no desorption will start. You cannot remove the gas molecules from the solid surface until and unless they acquire some energy of activation. So the shape of the graph is like this. So this is for chemical adsorption. So on the basis of the shape of the adsorption isobar, we can decide whether it's a physical adsorption or it's a chemical adsorption. Now since it is an exothermic process and decreases with increase in temperature, adsorption decreases with increase in temperature, physical adsorption is more common than chemical adsorption. So this is about the adsorption and the factors affecting the adsorption.